Hi, my name is Mark Rulo. I'm one of the mathematics consultants in the Learning Success Center at Wachusett Community College. In this video, I'm going to show you how to use a z-table for your statistics class. First, a little refresher about probability. Remember, probability runs from 0 to 1 inclusive. A probability of 0 means something can't happen. A probability of 1 means something has to happen. Most probabilities will fall somewhere between 0 and 1. Take as an example the rolling of a fair six-sided die. What's the probability of rolling a 1? That's 1 out of 6. What's the probability of rolling a 2? 1 out of 6. A 3? 1 out of 6. Every number from 1 to 6 has a 1 in 6 probability of coming up when I roll the die. I can graph the probabilities this way. Here the probabilities are equal for each number from 1 to 6. And the area under the whole curve is 1, because when I roll the die, I have to get either a 1, a 2, a 3, a 4, a 5, or a 6. No other outcomes are possible. This is a standard normal distribution curve. A lot of things in nature and in manufacturing will follow a curve like this. Heights, for example. A few people will be really tall, a few will be really short, but most will fall near the middle, or the mean. And this is a probability curve. The area under the curve is 1, just like in the die roll example. Everyone will fit somewhere on this curve. No one will fall outside the range of this curve. In a problem involving a normal distribution, you may be given the population's mean, abbreviated mu, and standard deviation, abbreviated sigma. A z-score can be calculated to show how many standard deviations an object is from the mean. For example, let's say the mean height for women in a certain country is 66.5 inches, with a standard deviation of 2.1 inches. How does a woman with a height of 67.4 inches compare with the mean? First, find the difference between the person selected, which is x, and our population mean. That is 67.4 minus 66.5. This person is 0.9 inches taller than the mean. But one standard deviation is 2.1 inches. So divide the 0.9 inches by 2.1 inches to see how many standard deviations this person is from the mean. This is how we calculate a z-score. Make sure you understand the formula for finding a z-score when you are selecting a single random object from your population. The formula says z equals x minus mu over sigma. We usually round a z-score to 2 decimal places, so in this example, the woman selected is 0.43 standard deviations above the mean. You can have a negative z-score. That just means a person is shorter than the mean. But remember, you can never have a negative probability. I recommend that you draw a picture for problems like these. Draw your standard normal curve, and then show the position of that z-score, in this case, 0.43. Once we have a z-score, we can ask some questions, like, what is the probability of randomly selecting a person shorter than this height? That's the area to the left of this position, and you would shade that in. Or you might be asked the probability of selecting someone who is taller than that height. That's an area to the right, and you would shade that part in. Or you might be asked for the probability of selecting someone between two heights. And then you shade that part in this example. Then we use the z-table. The z-table will be your best friend for this class. I recommend you print out a hard copy. And remember, there are 2 sides to it, one for negative z-scores and one for positive z-scores. Keep the Z-table with you in class, in the Academic Support Center for tutoring, and when you are doing your homework. Bringing to the beach is optional. For each of the 2 pages of the Z-table, there are 2 parts. The first part is where you look up a Z-score. The first column and the top row are where you read your Z-score. The first column gives you a leading digit, a decimal point, and a digit in the 10th position. 0.4, for example. This whole row is for Z-scores that start with 0.4. But note the top row. Here the numbers go from 0.00 to 0.09. These columns provide the second decimal place for your Z-score. When we read across the row for 0.4, then, we are actually finding the areas associated with the Z-scores of 0.40, 0.41, 0.42, 0.43, 0.44, 0.45, 0.46, 0.47, 0.48, and 0.49. The second part of the Z-table is the big cluster of numbers in the middle of the square. These are areas, specifically areas to the left of each Z-score listed. A Z-table is a probability table. Remember, the whole area under the curve is 1, and the areas given for each Z-score is an area of probability to the left of that position. For example, if we look up the Z-score of 0.43, we see the probability area associated with that Z-score is 0.6664. That is the proportion of the population that falls below or is smaller than that object or individual that has a Z-score of 0.43. Areas printed on the Z-table are always areas to the left of a Z-score, but we can also use the table to find areas to the right. If we were interested in the probability of randomly choosing a woman taller than the one we selected, we would look up the area to the left of her Z-score and subtract that area from 1. In this example, we would take 1 and subtract 0.6664 to get 0.3336. Let's say this woman's sister is 63.7 inches tall, and we can calculate her Z-score, which is negative 1.33. The area to the left of this height, or Z-score, is 0.0918. Now, what is the probability of selecting someone from the population who falls between these 2 heights, or alternatively, between these 2 Z-scores? All you have to do is find the areas associated with the 2 Z-scores and subtract the smaller area from the bigger. Why does that work? 0.6664 is the area to the left of the Z-score 0.43, and 0.0918 is the area to the left of the Z-score negative 1.33. To get the area between, just take away the part you don't want, which is this part, and voila! You can go the other way as well. Given an area, or probability, what is the Z-score associated with that area? For example, I want to know the height associated with the 35th percentile. This means 35% of people will be smaller than the height I am looking for. What is the Z-score associated with this percentile? And then, what is that height? Some students will convert the 35% into a decimal, 0.35, then jump to find the Z-score of 0.35. But this is not right. Here, 0.35 is an area. It's the Z-score we're trying to find. Put in a couple extra zeros if it helps, 0.3500. Now find that area, or as close as you can, in the middle of the table. This corresponds to a Z-score of negative 0.39. I always say you should draw a picture when solving these problems. If you're at the 35th percentile, You should recognize that this is a position to the left of the mean, which would have a negative z-score. You can convert this z-score back into a height if required. Remember, the z-score is just how many standard deviations a person or object is from the mean, and this person is 0.39 standard deviations below the mean. To convert this into a height, take the mean and add to that the product of the z-score and sigma, which is the standard deviation. Maybe you should write this formula down too. The answer to this problem would be 65.7 inches. Hey everyone, it's been a couple weeks since I recorded the earlier parts of this video. I was lying in bed last night, thinking of course about z-tables, and I realized I forgot to mention another application of the z-table. I couldn't wait to get back to the Tutor Center to tell you about it in this video. You'll be using this technique in chapters 6 and 7. The problem might be framed something like this. Find the critical z-scores for a given level of confidence. As an example, let's use a level of confidence of 90% or 0.9000. This 0.9000 is not an area to the left of a z-score, and it's not an area to the right. Rather, it's an area in the middle, between a z-score and the negative value of that z-score. Here's how you solve this. If, as in our example, 90% is in the middle, then what remains in the tails is 100% minus 90%, or 10%. This shaded area is centered on the mean, so the areas in the tails are equal, and each half of that 10%, which is 5%, or 0.05, or 0.0500. Now, find the z-score that gets us an area of 0.0500, or as close as you can get to that value. In this instance, 0.0500 is exactly in between 0.0495, which comes from a z-score of negative 1.65, and 0.0505, which comes from a z-score of negative 1.64. When you are exactly in the middle like this, take the average of the two z-scores. I get negative 1.645. The other positive critical value is then 1.645. Be careful how the question is asked. If they ask for the critical values, then give the positive and negative numbers. But if they want the critical z-score, they're just looking for the positive value, where it is understood that a critical z-score represents the positive and negative values of that number. If your z-table doesn't already have it, maybe jot down the critical z-scores for some of the common levels of confidence used in problems. But make sure you know how to find the critical z-score for any level of confidence. Let us know if there are parts of this video that you feel could be made more clear for an updated version. And let us know if there are other videos in this series you would like to see. As a reminder, here's the information for our website where you can find our current schedule, plus our email address and phone number. Good luck, and I hope to see you this semester in the Learning Success Center.